we have another bar that is making an angle. I don't know what's the problem with the things. Making an angle theta. Now we have this small ring P. Distance along this bar is R. This point is named Q. This is what is given. Anybody that doesn't understand the problem?
It's the fixed point, sorry, fixed rod. Directly on E3.
What do you mean? At this point we have a frame. Frame means a set of axes. We have 3 axes, E1, E2, and E3 vertically.
Oh, I guess I don't get what that
This bar is rotating by an angle 5t. Okay? Attached to it another bar that is moving with an angle theta in the vertical plane. Okay? Any question about that? About the description of the problem? If you don't understand the description, you'll not be able to proceed further, of course. So you need to make sure that we understand the description. Any problem? I know that I'm not good at delivering the description, so that's why I'm asking. Any problem with the description of the problem? Do you understand the problem? Understand the description? Okay, now this is what is given, and we need to add more frames. With any rotation, you need to add a frame. So we have first rotation here by an angle phi. We're going to have a frame here. So this E1 rotates to this axis, name it whatever you like, maybe I. The same E2 rotates here by the same angle to the axis J, and the rotation happens around E3, so it remains the same. IJK, K actually will be simply E3, okay? Any question about that? Then along that vertical plane, the blue plane, this red bar rotates down by an angle theta. So this rotation is about what axis? This theta is about what axis?
E2.
What? Oh yeah, that's okay. We're just I mean, there's no shape. I didn't just hear it.
E2.
E2. No. The E frame is gone. The E frame has gone. Okay? The E frame has gone. We started with E1, E2, E3. We already rotated by an angle phi to arrive at IJK. We're talking about IJK.
J.
So yes, so the angle theta is about J. Okay? So J will remain the same in the new naming. So in the new naming, I rotates down a little bit to arrive at this axis. This may be our last axis. I'm going to name them the body axis B1. K rotates a little bit. This is B3. And B2 is into the blue plane. Actually is equal to J. So this is B2. It's not the easiest problem and it's not the hardest problem. It's typical problem in our class. We always gonna have 2 rotations to deal with. We're gonna have this picture over and over again. So you need to understand what we're doing. If you have a question, no matter how naive it is, please bring it up. Yes.
Can you explain that more than more than 3, I guess?
Yeah. So the first rotation occurs in a horizontal plane, correct? Which means that E1 and E2 rotates to I and J. Okay? Now I have I, J, and K, the blue frame. it rotates in the vertical plane, which means that J remains the same. I'm not concerned with it anymore. I'm talking about I and K. I and K just rotates down. We need this picture anyway. Here is I, here is K. I'm not concerned with J because rotation happens around it. It remains the same. This frame rotates a little bit down by an angle theta. So this guy rotates down by an angle theta to B3 was the third axis, right? And this was the first axis. It is mandatory that you keep track of order. So this was the first axis and rotates in the new naming, don't name it B3. Because we need this order 1, 2, 3 in the cross product, right? 1 cross 2 gives you 3 always.
So the red pen is not very dark. It's not visible from the back.
Yeah, okay, let me use the green. Any question? Any question about that? Any question, please? Okay, so this is the description, what is required. This is a slide here, P. What is required? What is required is 3 things actually. Here are the requirements. D by dt in the body frame of the vector QP. D by dt in the inertial frame of the same vector QP. And finally, d by dt for the vector OP with respect to the inertial frame. This is A, B, and C requirements. So let's go ahead. We want to differentiate the vector QP with respect to time in the body frame. First, let's write the vector QP. So QP, what is QP? Anybody can tell me what's QP?
R we have 1/2.
So QP is R in what direction? B1 direction. And simply, I need to differentiate that. Okay, so d by dt QB with respect to the body frame, so with respect to its own frame, this is what? When you differentiate the vector with respect to its own frame, we just differentiate the component, right? So it's simply R into B1 frame. We're done. Okay? Any question? I'll give you some time to write, but you need to focus. Number A was easy. Number B, we need better change of QP, the same vector, but with respect to the inertial frame. Now we're gonna get that. Where we have the vector differentiation formula that we derived last time for any vector. I'm gonna apply it for QP. So d by dt in the inertial frame of QP equals what?
The individual dot plus the rotation.
The d by dt for the same vector in its own frame plus
Rotation.
omega cross the vector. What's omega? Omega between the two frames, B and E. I got this already. It's here. This is easy. It's R in the B1 frame. I just need the omega. Okay? So what is omega between the two frames? How you arrive, how you reach from the E frame to the B frame. To go from the E frame to the B frame, we went through how many rotations?
2.
2 rotations. So omega, I'm gonna simply add them vectorially. The first rotation is magnitude is phi dot, correct? In what direction? Yes, it is in the k direction. It is around k. So this is in the k direction. K or E3, whatever you like, they are both equal, right? This is the first rotation. I'm simply gonna add the second rotation. The second rotation by what magnitude? Theta dot as an angular velocity. In what direction? J. Or
K.
J or what?
J1.
B2.
B2, right? So this is omega between the two frames. Any problem writing omega, you will do it many times this course. You will do a lot of omegas. Any problem with this, please? Any problem? There is no shame here. If you have a problem, just bring it up. Okay. So simply I'm gonna substitute omega back here and I'm done. Let's just do it till the end. I'm gonna do cross product between omega and this vector. To do cross product or dot product or whatever between two vectors, you have to be written in the same frame. This guy is easily written in the B frame, the body frame, so I need to write omega in the body frame. Omega as a vector can be written in any frame. Any vector can be written in any frame. Okay? So I need to write it in the body frame in order to do the cross product. Well, omega has just two terms. This guy, the second term, is already in the body frame because it's theta dot B2, luckily. This guy is not in the B frame, so I need to write it in the B frame. Okay? So simply I need the relation between K and the B frame. And you can get it from this picture easily. Please write K in the B frame. Simply K is B3 cosine theta and B1 negative sine theta. Okay? Any question about that? Yes?
Can you repeat what you said?
Yeah?
Yeah. So,
I need to write omega in the B frame in order to do the cross product. So I need omega in the B frame, meaning what? Omega equal something in B1 direction plus something in B2 plus something in B3. This is what I mean by B frame. So this term is already in the B frame. But this term is not. It is something in K direction. K is not in the B frame. So I just went here and write K in the B frame. Okay? So omega is from here phi dot multiplied by K, and K from over there is negative phi dot sine theta in the B1 direction, theta dot in the B2 direction, and this term gives you also from over there phi dot cosine theta B3 direction. Any question about that? Any question? I'm going to do the cross product with RB1. So B1 cross B1 is 0. B1 cross B1 is 0. B2 cross B1 from over there. 2 cross 1 is negative 3. So this is negative R theta dot B3. B3 cross B1. From there, 3 cross 1 is 2. R phi dot cosine theta. So then, we're done from this part. D by dt of the vector QP in the E frame is equal to, the first part was simply R dot B1 direction. The second part coming from as is. So this is R phi dot cosine theta B2 minus R theta dot B3. I'll give you some time to write. I mean, you can write now, but always recommend that you focus when we do the work, because I'm fast, and then you will have time to write. Any question? Any question? Okay. The third requirement is the inertial time rate of change of OP from O to P. This is easy given the work that we already do. So D, OP, or let's write OP per se first. What is OP? What's the vector OP? How can you construct it?
HG or E3.
Yes, so let's write it abstractly first, which is OQ, right? Plus QP, correct? Any question about that? So if you want to do the time rate of change, simply pass it over with respect to the E frame, E frame, E frame. And we already got this. We already got it. It's over there. So I need the time rate of change of OQ. OQ is easy. OQ is what? OQ is what?
H.
H. In what direction?
E3.
K or E3, right? I wrote it in E3. Why? Because if I want to do the time rate of change with respect to the E frame, the inertial frame, it's simply H dot in the E3. It's already written in the inertial frame. So this guy is H dot in the E3 or K. So I'm simply gonna add H dot in the K direction to this green K. But like I said before, this is in the IJK, this is in the B1, B2, B3. You need to write K in terms of the B's, which we've already done before. So this is H dot times K, K is simply here, negative sine theta B1 plus cosine theta B3. So add this black guy to the green guy, you get the final result. Now I have time to write, and if you have any questions.
Just to be clear, you're saying DE because you're saying that that's the frame, the E frame?
Yeah.
Okay.
This is what is actually, this was the exact requirement. He wrote it like this, dE by dt OP. So this means that the derivative of this vector with respect to the E frame,
Okay.
i.e. considering the E frame as inertia.
Okay.
Any question? Yes, please.
So if we're trying to get it in the E frame, I'm not sure I understand why we're writing it in the B frame. Like changing it.
Yeah, this is a very good question. This is a very good question. So, the time rate of change of a vector with respect to any frame, I don't know, with respect to the E frame, for example. The result is a vector. After you do the differentiation, do it whatever you like, the result is a vector. As a vector per se, it can be written in any frame.